Hi, Sujesh.
At least I never. Yesterday was the first time I saw SIUC PHYS. I'm still working on the camera, so give me a few minutes. Go ahead. You were finishing. Sorry, I interrupted.
Okay, no. So
I'm interested.
I started doing that, and I've taken education classes, I've taken math classes, I've taken some business classes, and so I got a second master's in math education because I thought I don't want these classes I've taken to go to waste. And then when I just got to a point, with encouragement from friends of mine who were involved in pickup, I decided to go back for my doctorate.
That is this doctorate, or
Yes, this the one I'm working on. It was and because I really enjoyed the computation side, I did my research, and I found that we have the computational material science here.
I see. So what kind of so what's the experience you have in computation?
Well, a lot of mine is self-taught.
So okay, that's much more relevant.
I taught myself C++ to do these computers. Mathematica. I had been teaching myself Python, but over the summer I did a crash course with Bashari, and I know a lot more about Python than I did.
Okay. Oh.
And she's got me reading a book. Well, I'm trying to read it with trying to keep up with everything else, but atomistic computer simulations.
Animistic computers. What's the difference between animation and simulation? That doesn't matter.
Well, I think with this, with simulations, with animations, it's more focused on the picture, and with the simulations, you're actually trying to crunch the numbers.
Yeah. Yeah, you should talk. I'm interested. Maybe after the lecture, we can get this going.
Looks like there's going to be more people online.
Say that again?
Looks like there's going to be more people online.
Probably, yeah. It's raining.
Yeah, today's a good day to be online.
Yeah. I was actually, when I was just driving when it started raining, I was thinking that you will be the one who might try to be from online. You're the one who deserves to be attending online on a day like this. But
I got here before it hit, because I was in my office by 9 o'clock.
Yeah. Good.
It's really convenient because my office is right around the corner of the next alcove. It's
Next what?
next little alcove 414.
Got it.
So now I don't have to carry all my stuff with me.
Okay.
Every day?
Well, on the days that I come down, it's 2 hours.
Just 2 hours, right?
I know people who go to work 5 days a week and drive that far because of the area that we're at. It's such a, the limited economy that they can find much better employment.
I can guess that, yeah. But then even if you go to big cities,
You're driving.
you're commuting that long. I mean, you may not be driving, you might be
You're not
with
going
a train.
this far.
Yeah, you're not at all going this far, but it takes the same amount of time. So yeah, there's a bunch of, I think a good part of the population does this. Amazing, yeah.
Well,
It's determination, yeah.
my uncle goes to UFI, and he lives in Normal.
Oh wow, that's
So I don't know. I think it's like an hour and a half drive.
yeah, that's about what it
He
is.
does that every day. Yeah, I was saying, why don't you move to Champaign? Like, and he has a family in Normal, so it's really hard to live in two places.
Well, I went back for I don't know however many years they keep the schedules available to look at. And probably over 90% of the time, the graduate physics courses were 2 days a week. And I can work around that.
Right.
Is this okay? You think we can manage with this? Manage. Otherwise, I'll run out.
You
Is
want
everyone here?
contributions?
Oh, yeah. Almost. Right. Yeah. Do you have access to a scanner, for instance?
Oh, yeah, at home I do.
At home, you do. This one, because I think from what I see, everyone is submitting on D2, or at least
Okay.
half of them are. So it's just convenient to have everyone.
Okay.
I prefer this.
Before you said
And
you
I-
like
yeah.
a hard copy.
Exactly. I prefer this, and I said I want a hard copy. So then everyone is across the internet. So, and then I started figuring out the D2L thing. I don't like it. The annotation there is not convenient, but I'm finding ways to do it.
We used D2L in our school for 10 years. And I complained every day. And we finally went to Canvas, which is better. But everybody's trying to do the cheapest job they can. And so none of them have really good service and features.
Canvas has better. Is that the point?
It's more user friendly.
I see. I don't know. Yeah. I don't even use D2L properly. It's just that I'm forced to this time with the online thing. Otherwise, I like the traditional.
I think if you have pen input,
Come again?
do you have that external pen, like stylus pen?
Yeah.
I think if you hook it into your computer, I think you can
No,
annotate it
You
easily.
cannot. At least I don't know. You should tell me how it is done.
I
They have a curved line, but it doesn't work.
I don't know. You have to ask Dr. Martin about it because he does that.
Can he write?
I mean,
Does he have a write, like a curved line?
Yes,
Okay, I'll ask him. You should.
he does that.
It's not like this,
No,
like not straight lines.
no.
Like
It's
that
written.
written. Okay, I'll find out. Okay, as far as that's all I need. I just want to write something on it.
Maybe he just downloads the PDF and goes to some PDF editor and writes there and
Oh
uploads
yeah,
it.
then it's different. Yeah. Or else maybe he has a PDF. What do you say? Adobe Writer. I don't have one. I'm Linux person, so almost half of this doesn't work. It's a lot of things.
This seems to be Windows.
Yeah, but this is not mine. This is departments. This whole thing is departments, except the drop part.
You can use it to grade your homework.
No, it's not convenient. I don't want to do two things. Everything of mine is on the computer. See, there are many solutions possible. See, that's what everyone says. If you tell any problem, you say, oh, you can do this, you can do that. But I want a convenient thing. Like traditional thing is very convenient. I want that convenience.
Moving along.
Like we're talking about 50 students, like 55 students when you're grading. I don't want to do that on that computer and then transfer 50 files here and then make a database there. So yeah, so it's a lot of
Even Moses is not here.
even more.
It's sad.
Rob is the one.
I counted on Moses to be here.
You cannot compare anything with Rob. It's 2 hours. No, I'm not complaining about that. I shouldn't be the wrong message. Okay. Do it. Okay. So, everyone there, can you guys hear me? No one talked in the whole thing.
I was just listening.
Yeah, you guys are listening. Yeah. Okay. Is it raining for you guys? How about Saudi Arabia? Is it raining?
Oh, yeah. Come on.
But here it's raining. Almost the whole of south of US, I think it's raining, right?
Yeah, there was a storm, I think, a hurricane Laura or something.
Yeah, it
But
just,
thank God we don't have hurricanes here.
you guys have dust storms, right?
Yeah, almost all over the year.
Do you guys ever get rain?
What?
Do you guys ever get rain in Saudi Arabia?
Yeah, in some parts of Saudi Arabia, the southern parts of Saudi Arabia have like 3 months season, but the other parts, not occasionally you have rain. So you have sandstorms.
Okay. How bad are sandstorms? I can go for 2 more minutes. How bad are sandstorms, I asked, usually?
It depends. There is an empty quarter in Saudi Arabia. That part is
Can you
where
get
sandstorms
property damage? Can you get
almost daily.
almost daily? Can you get property damage
Yeah.
from sandstorm?
No, not that hard. Like the hurricanes in US, it's terrible for us. They are, they're just, missing everything around. That's it. No damages. See what I mean?
You don't have to move the sand around. Like, what if after a month or so, the first floor goes away, you're all underneath the sand? Does it happen?
No, that's only in small parts of Saudi Arabia, not the most of the country, not that far.
Okay, interesting. Okay. Nice. So we have
But we love it though,
We have what?
But we love it though. We love it. We love our weather here, our place, our land, everything.
I'm sure.
Mm-hmm.
Okay, let's proceed. So there was a homework due today. Right. Is this visible when more than half is across the internet?
It's pretty faint.
It's pretty faint.
I mean, we
Okay.
can see it, but it's not.
It'll be 5 more minutes. I'll go and get my pen. Get the pen. Let's see. You guys talk about weather. Okay. I'll be back with a marker.
Thank you. Quick run.
That would not be a fun class for you guys trying to see that on the.
Well, it's better than the alternative, which is drive an hour and 15 minutes and
Yeah.
nothing happens on campus. So I get there and then just turn around and leave. So that would be not great.
Yeah, I'm only 30 minutes away and it's a pain in the butt.
Yeah.
I think they're gonna change to the online mode because of the cases that are keep going now. So what do you think, guys?
I think it'll probably happen. I think it'll probably happen.
Yeah. Well, my friend in Iowa, in Ames, Iowa, he told me yesterday that they have most of the classes online, only one hour a week, every week. They attended the campus, and they have the whole semester is about 13 weeks, not 16 weeks as we do. So
I think our semester is shortened too. I think I could be wrong.
here,
Maybe it's still 16 weeks. They just changed it. I remember reading something about like we're not supposed to come back after Thanksgiving break or.
Yeah, we don't come back, but they're still having class. It'll just be all like this.
Oh, okay.
That's just a week of class and a week of finals.
Yeah, that's kind of strange. Why wouldn't you just do it all online? It just doesn't make sense to me. But I'm not the boss.
Yeah.
Yeah, I'd hate to be responsible for like a bunch of people. Like if professors start getting it and they're older and it's like,
Yeah.
they'll probably be
That's
fine.
the
But
problem.
imagine some lawsuits from professors, I'm assuming. They're forced to teach and they get it and get really sick. Because a lot of college students want to go out and party together or whatever and not wear masks, and we'll see.
I walk around campus sometimes and I see like a group of 7, 8, even 10 people. They're walking together and nobody has a mask.
Yeah. Yep.
Okay. Sorry about that. Okay. Should be visible.
Oh yeah, that's way better.
I look at the videos sometimes. I just hardly actually few minutes. It comes out a little hazy when I look at the recordings. Is it the same when you're seeing it live, or
Yes, it's
Like-
hazy.
slightly hazy? But you
Yeah,
guys,
it's hazy. Yeah.
do you have to guess what I'm writing, or is it usually clear?
As long as you're like usually when you're writing, you're talking. You never write something without mentioning it, so it's pretty easy to tell. The hardest one is when you switch to the other board and then you write in the left-hand corner. So when you rotate the board to the side and you write in the top left-hand corner of that board, based on where the camera is sitting, yeah, it's like you get the fishbowl effect where the corners of the board are really rounded, and so the top left-hand corner is difficult to see. But I mean, as long as you're saying what you're writing, I haven't really had any issues writing notes.
So just so that you guys know, I have the ability to zoom, right? It is possible that I do 2 shots of this at a time. So the resolution will get higher, but what you lose there is you don't get a bird's eye view.
I prefer, so sometimes like the first and second day we had class for each one of these, you were more zoomed in, and yeah, you could see it better, but there was a lot more like, hey, can you move the board? Hey, can you move the board? Hey, can you move the board? So I think it's better
Personally,
now.
I like having a bird's eye view. That's the advantage of a classroom, I suppose. You can move your head and see what's going on. Otherwise, you're localized. But let me know what you guys like, and I can do what. I just gave you the information that it's a possibility. Okay. So, okay. Homework 1. No, homework 2, right? Homework 1 was due today. Homework 2 is it uploaded yet?
Yes.
Okay, thank you. So, when is it due? 4th? No. Oh. 4th, right? Friday. But you should be probably able to do right after this lecture, and then there is midterm 1, which is September 14, Monday, and this is in class. We'll have to see how we'll manage in class. Half of us will have to be somewhere else, but we'll see. We'll try to figure that out. Okay. We covered a good bit of what was needed for doing vector algebra using the idea of a gradient. So that's the primary thing we did. We spent probably 1 extra lecture on it. We also pointed out that Gauss's theorem in differential form has this feature that so for a point charge, let's say electric field for a point charge, no time dependence. In general, this could be time dependent. In SI units is Q over R squared. I'm also assuming that, so this is point charge, a single point charge at origin. If it is not at the origin, what changes?
Should there be our hat?
Oh yeah, our hat, sorry. This is our hat. Important. Because it's a vector, right? What will, is this okay if it is not at the origin? What will change if it is not at the origin?
That R square will change.
R square will be changed to, so if it is not at the origin, this will be 1 over R minus R naught, where R naught is the position of the charge, the magnitude. And the R hat will also accordingly change. Right? This will be the new R hat. And so, but let's keep it at the origin for convenience. And we pointed out that if I were to evaluate del dotted with E, this is equal to 0 everywhere. So if R, I mean, we're not sure what happens at R equal to 0. So the best we can say is that R not equal to 0. So if you're not at the origin, however close you are to the origin, you can be delta. It's like a limiting form wherever it's, as far as you're infinitely away from the, infinitely slightly away from the origin, it is exactly equal to 0. And we also argued that if I were to evaluate over any sphere of radius r, sphere of radius r, right? Radius. Is that visible? Is that visible to you, Rob?
Yes.
Yeah. So, okay, so of del. So this is equal to, so this is 0 everywhere. So one would think that usually a point does not contribute to an integral. So it's good to remember this. I think we probably mentioned it. So if you have a function x, right, and let us say I'm going from point A to point B along x, and there is a function f of x that has been plotted here. And let's say this is C. So that's point C somewhere here. And let us say there is a small, this is C minus delta, where delta is a positive quantity. And this is C plus delta. And if I were to integrate the x of f of x going from point A to B, and then say that, oh, this is actually equal to, I want to do the new thing that I go in the limit, right? Limit delta tends to 0 of A to C minus delta dx and f of x plus C plus delta to B dfx f of x. And there is a small thing, so you would say, oh, this is not the same. So let's say the remainder, right? So the remainder R, which R is equal to C minus delta to C plus delta d of x, f of x. And again, limit delta tends to 0. And one can ask, what is this remainder R? Right? In the limit delta tends to 0, what could this R be? By the understanding of our integration, it is this area, right? The area of this tiny thin film that we can think of. And in the limit delta tends to 0, this really gets thinner and thinner. And what will this be? Let's say R in the limit delta tends to 0 equal to, in general,
Are you getting that done like the delta distribution stuff? Is that what you're trying
the
to do?
delta distribution, remind me.
Like the del x minus y for charge distributions?
That's tell again. I think I didn't get it.
Are you getting at like using the delta distribution for like charge distributions?
No. I'm just doing mathematics here. I'm just doing calculus, right?
I know. Is that what you're getting at?
Any function, I do an integral, right? Instead of going from A to B, integral is, remember, this whole area underneath this curve, right?
Yeah, you're doing the delta epsilon.
Function. Sorry, yeah, go ahead.
You're doing the delta epsilon calculus stuff.
No, yeah, maybe you can interpret it like that, but just take it, whatever I'm saying, maybe this is not standard, I don't know. But what I'm trying to point out is, what will happen to this integral if I take this out? Right? Like this is kind of superposition of, so this is addition of areas, right? Addition of this area plus addition of this area plus addition of this area. Area is linear, right? I can break the area into 5 pieces, and it should be the area, right? A1 plus A2 plus A3. Just a simple idea. And I want to point out something here. I see, for example, what's going on here is that we showed that this is actually 4 pi epsilon, right? No, 4 pi, no, this is just, what is this? This is just Q actually, right? If I do this for this, it comes out to be Q. Right? We did not have this feature in there. So, no, Q over epsilon, right? Q over epsilon. Okay. So my motivation here is that this should bother all of us, that this is equal to 0 everywhere, right? But then if you add up on a region, this gives you a finite quantity, which probably from experience in other parts of other subjects, or even in undergraduate electrodynamics, you might say that, oh, point charge has an infinite electric field, so this is infinity here, something like that. But this is very strange, right? It is 0 everywhere, but infinitely small. At one point, it is contributing everything. Now, let us say that's 3 dimensions. I'm making a simpler analogy here. I'm saying I'm doing an integral, right? So this is like area, right? Or a volume integral. So I'm just doing 1 dimension, dx. I go from A to B, and I want to pick out a point, exactly like here. I want to pick out 1 point, right? So I'm isolating that point. So I'm saying that C minus delta, C plus delta. So that's that isolation, right? Preferably, I mean, apparently that's some infinity or something. But now let's say here we have dx. But now tell me, I don't tell you what f of x is. There it was electric field and everything. Now tell me, if I have a function f of x and I split this area into 3 regions, and in the limit delta tends to 0, what is r equal to?
Just 0?
Yeah, it should be 0, correct? Because it's the area of the strip. And area of a strip is length times breadth, right? So area of the strip will be equal to, so this will be in the limit delta tends to 0. Breadth is 2 times delta, right? That's the width of the strip. And the height of the strip is f of c. Correct? So it's multiplied by a 0 times some value, which is expected to be 0, except there is one small catch there, right? So this is equal to 0, correct? Very correct. Is that all? Is there anything we are missing? Is that always equal to 0? Is there any loophole there? Something multiplied by something, is it always 0? It is usually, but we're talking about all possibilities, right? Here also, have this analogy.
Well, I guess if f of c was infinity, that would.
Yeah, if this was very large, for example, if f of c was 1 over delta, right? Let's say 1 over c, yeah, 1 over delta actually. Yeah, 1 over delta. Like f of c was going like 1 over delta. Delta and delta will cancel out and it can give you a finite answer.
So
Mm-hmm.
your goal is to basically, you're wanting to extract a single strip.
I'm just saying that give me any function f of x. Is this always 0? Is there any room for this not to have 0? Because that's what I'm getting here. I want to understand this. How can this?
If x is equal to y, then it's equal to infinity. And if x doesn't equal y, then it's equal to 0.
That is y.
I'm just saying, not y in general. I'm just saying, like, if you have if the strip, how would I explain this?
The length and width, let's say, or the height and width.
Yes.
Right?
Yes.
So if the height is inverse of the width, then I can make the width as much as I want. So for example, if you have this to be the strip, and this is your x, and the height is 1 over x, right? And area of this is x times 1 over x, correct? For any x, I can make it as small as I want, and this is always equal to 1. Like so, which is counterintuitive because usually it is correct. I mean, if you actually squeeze the strip, it should go to 0, and which is what usually we will learn in undergraduate calculus, that I can pick out a point from the integral, and integral is the same. Integral does not depend on a point. Like I can remove this point, and this is fine. Usually you learn this as integral of a to b is the same as a to c and c to b. That is what we learn in calculus. So this should be 0 incorrect, but that assumes that the function is nice. Like usually the language's function is nice means it doesn't go to infinity somewhere. But then we have that feature here that it actually is not a nice function in that region. So we have to deal with it, and that's what we want to do. And so this is or whatever this is, if right. So let's say if f of c tends to infinity, right? Maybe then it's not 0. We don't know. If f of c is not equal to infinity is not a correct statement because you don't say infinity is not part of a number line, so it does not tend to infinity. That's the way to say it. So if I use the language, I don't think this is correct. So this does not tend to infinity. Right? So it's a finite number, then it's okay. Right? That's the idea, and the same thing here, right? So we want to use the same feature here. So all this seems to suggest that whatever that area example I gave, so we want to introduce something called a delta function. delta function will be exactly these two information together is what defines a delta function in principle if you want. I think of every time you see a delta function, think of a point charge. What is its charge density? That's the best way to see it. But let's mathematically do this. Let's say we are in one dimension for a moment, and we will extend this to 3 dimensions immediately. So we will use, as the letter goes, this is delta function. So this is delta. Right? You can write the Greek letter. We don't have to write delta function. So it is delta function. It has the so this is f of delta of x, let's say, and this is x minus a. In general, it can be just x, so delta of x minus a. This is equal to 0 if x is not equal to a. So pretty much like this, everywhere it is 0, but it tends to infinity if x is equal to a. But that's not sufficient. A lot of things can go to infinity. It is also needed as an added feature plus, right? So the x delta of x minus a of any region, right? So for example, a minus delta and a plus delta. I don't need to put any limit on delta. I can make it so it's not in the limit, but it is also in the limit for any positive delta. Right? So this is equal to 1. Actually better, let me write it in a different way. Okay.
So I have a question for you really quick, because the part about what you wrote that I don't understand is you write the as it tends to infinity. It's when x is equal to a, it tends to infinity.
If you want to
for all x not equal to a, or for all x equal to a, it's equal to infinity, I thought.
but all
Tending towards infinity, because then it wouldn't be for all x not equal to a is equal to 0. That's the part I don't understand.
a is 1 point, okay? A is a unique number, let's say. On a number line, there is a unique, so this is x and this is a, the unique number on the number line. If you are not at that point, it is 0, and at that point, it is actually infinity, but then it's not okay. Like usually it is discouraged to write equal to infinity. So it is okay if you feel comfortable about this, this is okay. That's exactly what I mean. But then since infinity is not really part of the system itself, so the best I have to say is that it goes to infinity. Or let us all, okay, how about this? If you don't like that, you can even forget this. I don't know what it is at x equal to 0. That's a better way of saying it. I don't know what it is.
Okay.
But what I do know is that if so this is 0 everywhere. Think of it this one. It is 0 everywhere. But if I were to integrate from, let's say, some a to b, like there are 2 numbers, this is equal to 1 if a is less than a and b. This is equal to 0 if a is outside, otherwise. I think that's a better way of saying it. That way I am not invoking infinity at all. Right? What I'm saying is the function is 0 everywhere, but if you integrate it, it's not 0. Right? Kind of.
Okay.
And the only possibility is that it is actually goes to infinity right at that point. But then it goes to infinity, as you say, is not good because approaching needs some region, right? Some finite, even if it is infinitely small region, I need that region. So yeah, just avoid this. I think this is exactly what this is. I think it is better not to say this. However, I like it this way. Yeah, I usually just say it the other way, but I think when I think about it, this is just this. Yeah. Right. And this has the fact that this has to be infinity, right? At x equal to a. Okay. So let's do an example, right? How can you say? Can you even have such a function? Right? The immediate. I mean, as you're trying to imagine, how do you imagine that to be going to infinity? Usually, you introduce a third parameter. Like in some limit, you want to have that construction, so you will invoke a third parameter.
So is the goal here, you use the word like extract and when you talked about the function before. So similarly, when you have like the Kronecker delta, you're extracting terms from sums. Is the goal to extract terms from integrals so that you can do?
Yes, yes. As far as idea goes, it's the same, but in Kronecker delta, you don't have this issue, right? In Kronecker delta, you will never get an infinity, right? Because you cannot make it 0. Is that clear what I mean?
I think so, yeah.
Kronecker delta is either 1 or 0, right? It is 1 or 0. Here it is infinite and 0.
Yeah.
Right?
Mm-hmm.
So it's a kind of, yeah, but the idea is the same, but instead of 1, this is actually infinity.
Okay.
And it's only at one point. And that throws you, or if you're into rigor, especially if you use the basic standard mathematics, you're thrown off completely. So we have to deal with that. And it is not infinity in the sense of the word infinity. There are various kinds of infinity, right? For example, limit of x tends to 0 of 1 over x is infinity, right? And this is also infinity. 1 over x square, for that matter, any power is infinity. Log of x is infinity, right? X tends to 0. These are some of the standard simple infinities that you get. But each one of them behaves differently. X multiplied with this will give you a finite number. X multiplied with this will give you infinity again. Right? So this is what it means to say what kind of infinity it is in very simple terms.
Okay.
Right? In what sense, how does it grow? I think that's a simple way of asking. It surely grows, but you want some more detail. Like it's not necessary to say that something is going to 0. You say, how fast is it going to 0? And that's the structure of infinity. Right? How fast is something going to 0? Invert it, and you have a certain kind of 0. Okay. Helps?
Yes.
Okay, so let's take a very simple example and I mean, of course, that area example that I gave, that's a classic example of, yeah, let's first do, okay, so delta function can have various representations. Oh, I have to change the camera. Okay, good. So let's say representation 1 or example. Example is not the right word. Probably representation is a good word. Usually you say distribution. Like that's the way, because this is delta function is not a normal function. If you're into rigorous mathematics, they will outright say that this is not a function. End of story. We don't do anything about it. But in physics, you don't have the choice because you have a point charge. That's the most basic structure. You don't want to give up, so you have to deal with it. So you construct what is called a distribution. So I will just call it an example. Let's just state that. And let's say f of x is the following. F of x is equal to I think
Q.
no, Q. The same. I'm just constructing that rectangle that I drew earlier. So it is equal to 0. No, it's equal to 1 over x, correct? Give me a second. Oh. Yeah. Okay, let's draw this. So I want to have a function of this kind. So this is a, yeah, so there's a new parameter. So this is a, and that's 1 over a. So I want to say this function is 1 over a if x is less than, let's say, x equal to 0. So this is a over 2 and greater than minus a over 2. Okay. And it is equal to 0 otherwise. Good. And let's ask the same question. Remember, our delta function has to satisfy two. Oh, and I want to do, yeah, so let's define that. And let me define my delta function to be limit a tends to 0. Don't confuse this a with what I wrote earlier. Should I change this now? Yeah, you will manage. A tends to 0 of f of x. Let's check the two statements that I said is true or not. So statement 1, right? So statement 1, let's say. Statement 1 is that delta of should be 0 when x is not equal to 0. Delta of x when x is not equal to 0. Again, don't confuse this a with what I wrote earlier in that delta function definition. This a and that a is different. Okay, so don't confuse. And then if x is not equal to 0, if x is not equal to 0, it is 0, right? In the limit a tends to 0, this gets squeezed in, and if x is not equal to 0, I'm in here. So that's equal to 0. That's clear? Right? It's more of a definition. So that's correct, right? That's valid. Statement 2 is that limit delta x going from anywhere where enclosing that a to b delta of x is equal to, since it's in the limit, this is equal to 1 over a. Again, this is this area that you will capture, right? The limit, this will go to infinity, so that's area is 1. So this will be just 1, right? Graphically, let's say. Use graphic. That's one way of getting that. Unless if a is less than 0 and b is greater than 0, and otherwise it is 0 again graphically, right? So if this squeezes out and your a and b is on this side, then it's equal to 0. Otherwise. So there, it's a good example as far as visualization goes, but then you don't algebraically you don't see it. So if you're very algebraic, then you may not feel comfortable about it. So let's do another representation. Any questions at this stage?
I have one quick question.
Yes, please.
What if, so if we had like capital A equal to 0 and then B greater than 0? Like what happens if one of the bounds is equal?
Good point. Good point. Okay. If A, good point. How should I define that? Did I need it? Okay, let's go back here. What happens if A is otherwise, right? Oh, so because in this otherwise, there is a problem probably, right? Let me change my definition of the function. We will talk about that. That's slightly tricky because we are do theta function there. As of now, that's not well defined. I think that's the easiest way of saying it. Let me go back a little. So here, yeah, in this definition here, let me make this better actually. So if this is equal to 0, if A is less than A and B is less than A, right? And this is equal to 0 if A is less than A and A is less than B. So that way I avoid that whole problem of sitting right on that point, right? So here, what I've left open is, I don't know at this stage if A or B is, A or B is equal to A. Now, it turns out that sometimes it does happen that you have to deal with it. And then often, again, since it is not well defined, you can pretty much average the point and get away with it because it is under an integration. So that's a hint I can give you. But as of now, I think it is safest to say that it is not defined. Okay, it's ambiguous at this point what that is. So, but we don't need that. I will leave that open completely. So delta function doesn't need it, right? So we just need this function. Okay, so that makes it better. So I'm avoiding that whole discussion. Okay. If I just to give you, since the question came up, at least you guys can explore the following thing. So let's say this is x. And let's say we have a function of this kind. So this is called the Heaviside step function. So this is x equal to 0. And that's your function. And we will define what is called Heaviside step function. This is equal to 0 if x is less than 0. And this is equal to 1 if x is greater than 0. And this is called the Heaviside step function. And again, the same question comes about as to what is at x equal to 0, what is this equal to, right? We can, it's not very clear what that is, but interesting point is, again, we can, one of the representation of delta function is, what is derivative of the step function? Right? It is 0 everywhere on the left, 0 everywhere on the right, but probably, especially if you can think of this as a function like this, and then take the limit this way, this will actually give you again the delta function. And this is tan hyperbolic x. That's the function you can think of. Tan hyperbolic x is a function in the limit. It becomes a step function. And this is okay. But then again, now it gives you a room here as to, oh, what should I do at x equal to 0? Is there any possibility of defining that? And it turns out that if you were to average this, theta of x, theta of 0, if you were to define this as 0 plus 1 over 2, right? Maybe it is a a possibility, and that goes through. In fact, there are other possibilities. It is ambiguous. But since the delta function always comes under an integral, that's okay. You can get, that's one way of approaching it, at least in some systems, this has been shown to be true. I should also say that in mathematics, or I should say in applied mathematics, there is a whole discussion on this. Like, it is not a settled point as to how do you define this and how does an integral or a delta function decide. Does it depend on the averaging prescription? If I call that an averaging prescription, does it depend on that? So it does. It is addressed. Is there a solution? I would say no, not yet. But it is discussed. That's the best I can suggest. So that's probably the best answer I can give there. But we will probably not need that. If it is, I will point it out. Right. Yeah, let me leave that there. Good question. That's the best I can say. Else? Okay, did I convey reasonable points so that you can think on your own or find and figure out? Right. Yeah. Okay. Any other comments or questions? Okay, so let me do another representation, more algebraic, a lot more natural in a sense, rather than this. I would say, let's say, what's that? Another example of representation of distribution actually is, let's say, first let's consider f of x to be I think it's this. And so this is epsilon is any number, and now let's say delta function is equal to limit epsilon tends to 0 of f of x. Okay, and let's first of all do delta of x. Let's evaluate this at x not equal to 0. Right? So let's say x not equal to 0. If x is not equal to 0, if x is not equal to 0, whatever this is a positive number. Eventually, this will become much smaller than this, like in that extreme limit, because it's a whatever this is, it's not 0. In that limit, this will always get smaller. So this is equal to limit epsilon tends to 0 of epsilon over x squared. And since x squared is not 0, numerator takes over, so that's 0. That surely satisfies the first condition. Just let's, so that we talked about if x was not, or if x was equal to 0, this should change its behavior. So let's see what happens if x was equal to 0. X was equal to 0. So delta of x is equal to limit, again do the same thing, tends to 0 of epsilon over epsilon squared, right? So it's already 0 to begin with. And that's 1 over epsilon, and that's infinity. So that's the behavior, the sort of behavior we're looking for. But those two conditions are not sufficient, or first one itself is not sufficient. We also have to make sure that everywhere it is 0, but when you integrate it, it shouldn't be too large, it shouldn't be too big an infinity that when you integrate it, it blows up, it still blows up. It should just balance out when you integrate it. Right? So let's do x epsilon over x squared plus epsilon square. Here, that is this, so this is a to b. And let's say what should we do? No, we don't want to do it. That's how do I suppose? Let's do minus infinity to plus infinity. That's better. Right. Yeah, let's try to do that. Yeah, first let's do that, and can we capture the other part? Okay, first let's see, and if it was integral of delta x, it is like saying first we are taking the limit epsilon tends to 0, but let's so limit something going to 0 and integral, is that reverse or is that interchangeable or not? One can raise that question, but if I slightly get sloppy and say that okay, epsilon will be taken later on, so let me take limit epsilon tends to 0 later. Again, when you're adding, these things are okay. If this is a convergent quantity, these are all fine, but there is a fine point here. So we, this is where I say, like earlier, there was a discussion as to, is it okay to say that numbers, when you add up, it is -1 or -1/12 or not? And I said, if you're careful, it is okay. So this is a place when you change your limit and integral, if you know what you're doing, then it's okay. But sometimes it might fail also. So in this case, it works. So that's the way to put it. So this doesn't mean that always you can change integral and limits. But if that is done with that caveat, if I proceed, this is limit epsilon tends to 0 of what do you substitute here? So one can substitute x is equal to epsilon, I think tangent theta. Or tangent here. And probably I have to be careful. There's a pi somewhere floating around. We'll come back to that. So dx is equal to epsilon secant square theta theta. So this is when x theta or x is equal to -infinity, that's -π/2, and x is equal to +infinity, that's +π/2. That's dx. Dx is epsilon secant square theta theta, and this is epsilon again. 1 plus tangent square theta is secant square theta. Again, this cancellation notice, that's the relevant point, and even the epsilon cancels out. That's the important point. So only if that happens, then can this limits be introduced. So there's a fine structure there, pretty much like in complex analysis, where you do similar things. If you know what you're doing, it's perfectly fine. So this is pi, right? So this is equal to pi, but you don't want pi, right? You want 1 actually. So what I will do is all the way go back and put that 1/pi there. Then everything is good, right? So this is 1/pi, 1/pi. And this is 1/pi, and 1/pi, 1/pi, and this is indeed equal to 1. I've only shown this to be from -infinity to +infinity. If you take a finite value, how does it work if it's a finite value, right? But then this is a small angle here, and yeah, how about this? I have to give you an extra credit, right? I'm not immediately able to see this solution. So extra credit, right? Check out what happens if A that is less than 0 and B that is greater than 0. If you were to do this integral, does that give you 1, right? And the limit epsilon tends to 0. I'm sure this should be 1. Sure, it has to be 1 because this is a delta function. Probably you have to do complex analysis here, probably. That might be one way of proceeding, but yeah, I'm not immediately seeing. Maybe there's a standard integral. Yeah. Okay. So that's an extra credit. Check it out. Okay. If it does not come out, then we'll think about it. Okay, so that's pretty much your definition of delta function. But at a user level, this is all to give you an insight into what a delta function is. At a user level, how do you evaluate it? Our main goal is that there are point charges, right? So, I want to write, when I evaluate it, delta divided with E, this is equal to 0 if R was not equal to 0, and integral E cube R of this quantity, any sphere enclosing R equal to 0 gives you Q over epsilon naught. So you want to put this together. What does this mean? You say that this is now actually equal to del dotted with E is actually Q over epsilon naught. Let's write epsilon naught here. This is equal to Q times wherever the charge is sitting, it is sitting at the origin. So I'll say I have to set x equal to 0. Right? That's x equal to 0. I also need to set y equal to 0. That's y equal to 0. I have to set delta of z equal to 0. That's what this means. Is that clear? So I'm picking out as, so how will you say that the charge is at the origin? You will say, oh, x, the position of the charge is x equal to 0, y equal to 0, z equal to 0. Or you would say the vector r is equal to 0. Different ways of saying the same thing, right? So you would say, this is one way of writing it. Second way is that this is delta of r. So notice the moment I wrote a vector inside, that means there are 3 delta functions in here. And that sometimes is confusing. So I will try to avoid this description. This is what your textbook uses. Schwinger's book uses this form. So I will try to avoid that. What I will do is I will add on. So this is like doubling things. So this is, I will make sure that I want to show that this is 3 delta functions. So this is on. One can argue that this is not a good language because of 3 delta functions with r equal to 0. Because the understanding is that the argument of the delta function you equate to 0. But this is what I will use primarily so that this 3 tells you, gives you a clear idea that there are 3 delta functions. I won't use argument to clarify that. So probably there's an issue in that notation, but that's what we'll use. But in general, we can use any one of this. Again, what do we mean by this? Delta cube r, right? Or especially q times this. Right? This is equal to charge.
What do you have above the del there? I missed that.
Actually, oh, you cannot see it.
No, I can see that one. I was on the line below that.
Oh, here 3, again 3, same thing.
Okay.
So this is what I will use. That's what I was trying to get at. Right? So usually you want to read a delta function as delta function of something here. Right? Let's say a statement. Statement. Right? You always set the statement equal to 0. So the delta function contributes whenever the statement is true, let's say. Or statement is equal to 0, actually, not true. So whenever the statement is equal to 0, the delta function contributes, otherwise it does not contribute. That's a way to read it. But in that sense, then you would say, oh, r equal to 0, there are 3 of them. So that's the ambiguity I was trying to say, but I will try to use that anyway. Okay. Think of it, what we are saying here is a delta function should be interpreted as an infinitely small, inverse of infinitely small volume. So Q over infinitely small volume. So charge over unit volume. So that's charge density. Charge density for a point charge. An ideal point charge has no volume associated. It should be charge is 0 everywhere except at that point. But at that point, this is infinitely small volume. But if you have integrated over it, it gives you actually Q. Point charge at position R naught. Right, that's a position of the charge. Then it's charge density, Q rho of R. This is charge density. Is equal to Q times delta Q R minus R naught. Okay. So it's pretty much a way of saying defining a charge, if you want. What is the dimension of delta function? Delta of x. What's the dimension of delta function? 1 over the dimension of x. If it was time, it is 1 over the time. And whatever is the argument, you inverse of that is the delta function. So, okay. So now, where do we use this? See, what we are talking about is very quickly we will talk about charge distribution from here. What is the electric field due to a charge distribution? Point charge is the simplest quantity. So let's say line charge, uniform line charge on the z-axis, let's say. We have done this in introductory physics. We would say that this is a z-axis, and here we put a positive charge everywhere on the z-axis. There is a positive charge, and it is uniform charge distribution. Think of it as a wire, right? But it's of infinitely thin wire. Right? So that's what it means to say that you have charge distribution on the z-axis. So what will its charge density be? That's what we are interested in. On the z-axis, right? It's right at x equal. It's right at x equal to 0 and y equal to 0. So whenever x is equal to 0, it contributes. whenever y is equal to 0, it contributes. And when z is equal to 0, it doesn't, you don't have to add in the third system because the line is given by x equal to 0, y equal to 0. But what will you write here? And what is lambda? Charge density. So what you will do is, okay, so let's write something here. We don't know what this is because earlier it was charge. But now let's say lambda, right? But then what is lambda, you will ask. So let's integrate over this whole thing. And you can integrate over any volume you want. Integrate over any volume on a cylinder, let's say of length L. This is dz minus L to plus L, let's say, and the x going from dx dy, and this is on a radius r, let's say. This is our cylinder of radius r, and that's rho of r. But delta y contributes only when x is equal to 0. So you immediately have, there is no z dependence here. So this is 2 times L.
Do you have integral of dz, dx, dx? Am I missing something here?
dx, dx, yes, that's what I wrote. I meant dx, dy. Sorry. Yeah, thank you. But these two integrals immediately give you, using the delta function property, 1. Minus L to L gives you 2L, so this is 2L times lambda. But I should get the total charge here inside in here, right? So this is also equal to, so total charge. The charge is equal to 2L lambda. So this gives you an interpretation that lambda is actually charge for 2L, which is the length of this of the cylinder, right? So I should say 2L. If I go from minus L or plus L. And so that's charge per unit length, that's all. Right? If it is uniform, clearly the total charge on this whole wire, if it's an infinitely long wire, L is infinite, charge is also infinite because it's very long, but lambda could be uniform. And in your homework, what you do is write this different distribution. For example, if you have a point charge, if you have a disk, uniformly charged disk, and let's say it is infinitely thin disk, infinitely thin disk of radius r. And you can ask, how do you represent this as using delta functions? And you can also use step functions. For example, if you want to confine this to radius r, so an example could be, so how do we define this r? The total charge, let's say, is q, but we don't know that. So let's say this is some constant c times, let's say this is on the xy plane. Let's also say it is at the origin. So this is x, y. So delta of z, right? Surely it sits in a plane where z is equal to 0. But there is no restriction on x and y except that this has to satisfy the step function. So let's invoke the cylindrical coordinate. Rho has to be less than r, right? So r has to be greater than rho. Remember, this is the Heaviside step function, and rho is equal to x squared plus y squared. It's not clear what c is, but what we should get is that if we integrate this over the whole space, so all space, this should give you charge q. Right? That determines c. So that gives you a way to get your charge distribution for some quantities. And that should actually be sufficient for you to do homeworks. We will do few more properties of delta functions, elementary properties, not too sophisticated. Later in the next semester, we need more general formulas, so we will I'll introduce that, and then we will on Monday we will start writing the Maxwell's equation. So we'll proceed into the subject actually. I think this is basically the preliminary steps. Okay. Any questions? And I went beyond.
You plan to cover like the continuity equation and the Lorentz-Force law?
Yes, we will do all that starting Monday. Yeah.
Okay.
Yes. Why did you specifically ask continuity equation?
Because it felt like, I didn't know if it felt like we were kind of skipping that portion.
No. That's the first. We'll write down the Maxwell's equation, then write the continuity equation.
Because it seemed like we were like already into, you jumped to, you know, Gauss's electric field law kind of with all this, the general coulombs.
Good point. This is just to motivate the delta function. That was my goal. But now on Monday, I'll write Maxwell's equations, and almost every class I'll start with Maxwell's equation. That's how it's going to go. So now we'll do E and M proper.
Okay.
So continuity equation will be the first thing that will come up. Okay, thank you. So Rob, do you prefer to put it on D12 or do you prefer this? Is there any preference you have?
I can put it on D12. This is easy. I mean,
It's just that it's uniform, and that's all.
right. It's just, it's one of those things that I was doing some finishing touches this morning when I got here. So
Then it's fine. So
okay.
let me take.
If I'm done by Thursday, I'll scan it and upload it. If I'm still
Actually, I understand. Yeah. So I will scan it and send it back to you, something like that. Yeah. You drive a lot, so I can't tell anything to you. Okay. Any comments? Anything else, guys?
Oh, by the way, when you grade on D2L, I use my Surface Pro.
You have
It has like a Surface Pro, Microsoft Surface. It's got like it's got a pen with it. Makes it.
I have a pen with it, but then what do you do? Then does it allow you to? At least in my case, it doesn't allow you to do.
Now I remember. I think if you open the PDF on Microsoft Edge, then you can write whatever you want.
Yeah, but I don't have Microsoft Edge. That's my problem. I don't have anything Microsoft.
It won't do it on OneNote.
I don't have OneNote.
Okay.
What do you use with a pen? iPad or?
I use a Linux PC, like a laptop.
Yeah.
But
Okay. So it's got like tablet mode where you can like flip it into a tablet type.
No, I connect a vacuum tablet to it.
Okay.
It's like a mouse. So that's a good tablet. It's just that Linux usually, or it's not the problem with Linux, all these softwares do not make things compatible with Linux. They don't have.
You just use Ubuntu? Is that what you're using?
Yes, exactly. Yeah.
Okay.
So
Yeah.
that's really a challenge.
That's a little more unfortunate, I guess, if you use Ubuntu.
Yeah. So that's my challenge.
You use Ubuntu a computer that came with Ubuntu?
No. I load it. First thing I do is I delete everything and then load Ubuntu.
So you bought a computer with Microsoft on it, more than likely, and then you.
That's correct, and then I delete it.
Okay. On the back of your computer, it should have a code, your Microsoft code, so you can dual boot your computer.
I know, but usually what I do is, first thing I do is delete it because that gives a lot more convenience. I just don't, I never use it.
But you can, what I'm saying is you can download Microsoft for free and you already have a code on your computer that should allow you to install it. If you wanted to dual boot.
If I don't have a system of Microsoft Word, why should I install it? I use Ubuntu.
I'm saying you can dual boot Ubuntu and Microsoft
I know.
on the same computer.
Yeah, I don't want to. That's too.
Oh,
See, I have a Windows system. The one I'm seeing you on this, that's what I think Avinash was also suggesting, is that I have a Windows machine. The one that I'm watching you guys is a Windows machine. Right? So, and that's a school machine, so probably it has everything. But that's what Avinash was suggesting. That's too much work for me that I don't even use that. And probably I'm not friendly with Windows. Like it's like saying if you're used to iPhone and you work on another phone, you lose all your fluency in that. Now, I know it sounds like I'm whining, but it's just convenience at this point.
I understand.
Yeah,
none of it's convenient, but
yeah. And especially for 55 students, I mean, that's the major thing I'm having now. That's the only reason why I'm actually even exploring this, because I have another class. Moses is my TA, a teaching assistant for that. So I have to grade there. So that's the only reason why I'm even exploring it. Otherwise, for you guys, I wouldn't do it. Last semester, I just printed and scanned and did it again. It's a little more work, but I was ready to do that instead of doing all these new things. I don't find them any useful, D2L.
Yeah, the D2L grading, the actual, so I struggled a lot with that at first whenever I did 253 or whatever the class was. It's not a good, the grading system itself isn't very good. And it's hard to write on using a mouse, that you kind of have to have something else. But my Surface worked nice for it because I would just open it directly into a file every time and just grade everything on the Surface and then upload them. It's kind of a nuisance, but once you get used to it, it's not too bad, I guess.
Maybe, yeah, that's what I will eventually do since I have this computer. Every time I have to grade, I'll have to open this computer and do something.
I think the hardest part is that if you want to add details or tell someone where they did something wrong, you just kind of got to get over that aspect of it and then just tell them, circle the error and say something brief. And then if they, have questions, you just tell them to contact you or whatever. I think it's the best way to do it.
I did put, you guys got my grading, right? I did grade yours something, right?
Not sure. I haven't actually checked any of the grades.
I did do it. So I used some.
Are you talking about?
Let's see.
Are you talking about the extra credit?
Yeah, extra credit. Yeah. So there I commented on at least some of you guys.
I've seen the comment.
Huh?
I've seen the comment.
You're seeing the comment. Not on the right side, like on the page itself, right? Sometimes I write good.
All I see
10
is
out of 10.
thanks.
Huh?
All I see is thanks.
Thanks. I never put thanks.
Thanks for the information or something like that.
I didn't know. I usually thanks. What did you write?
And
Oh yeah, this was about the grades. Yes. I did say thanks because you guys actually, some of you guys really wrote nice things about the grading part. So I never expected that I will get such a response. So there I wrote thanks. Yeah, usually I don't write. Yeah, good point. Yeah. But sometimes that's where I cannot write equations. That is my big issue. But I do comment on it. So I click mark and then it opens a comment box and then I type something. That's what I've done. At least I don't know which class I've done, but I've done that much. I've learned. But I don't see how I will write equation if I cannot write fluently. But it's encouraging that you guys are saying that if I'm Microsoft, then I can do it. And anyway, you're using dual detail.
You can do it in Ubuntu as well. I mean, you can run any program you want in Ubuntu. Just download Wine or something like that, and then.
Yeah, I don't want to do all that. No. Yeah, that's what I mean. Yeah, so you want to do 10 things together, or to download Wine, I'll have to do something else.
No,
yeah.
just download Wine, then you can open any Microsoft program through.
It's like, okay, it's like saying you said dual boot the system. I lived with dual booting the system for 10 years. It's not straightforward. I mean, I don't like it. It's like make it convenient also. Yeah. Like reasonably
Sometimes you just gotta catch up with the times.
I've used one, and it's not that bad. Like you have to download it, and you have to, there's work on the front end to figure that out. But then once you figure it out, you can open, you can open the programs that you want to open, and you never have to worry about it again. So it might be worth it.
Sudo apt-get.
Okay. So here is my experience based on all this. If you're good at it, like when I was a grad student, I had a lot of time. I used to figure this out. You spend a lot of time, you figure this out, and it works. But after a while, you don't want to spend so much time. It's not a learning experience. This is like fixing something. Tomorrow it will be something else. It's not any logical thing you're learning. It's not a programming you're learning then.
Mm-hmm.
So I didn't find it very very educative in that sense.
Well, you should tell SIU they need to spend more money on online education, and then it would be helpful because there's lots of great things that they could have, but they don't have. Like even CMOS, they used a program called Moodle, and it was even better than D2L, and it was pretty bad too. But
very few people use Linux, so that will be not appropriate.
Yeah,
so it's my choice to use Linux, so I should spend my time.
Hey, my one Linux story is in high school. I put Slackware on a computer, and I spent probably 2 to 3 months getting the computer, getting all the appropriate things in order to even just get the internet to work. And what I didn't know, and none of the guides that I was reading told you to do, is that if you turn your computer off, none of it gets saved. So I had left this computer on this desktop in my basement of my parents' house for like months. I was like, it's probably a good time to restart my computer. So I restarted the computer and I booted up, and there was nothing there. So it was like 3 months of work gone.
Yeah. Always happens. Yeah, for me, I think it is just a handicap. I've got so much used to it. I have so much flexibility in there. Now I'm too old to change. So I hope.
Not that old. My grandma uses Facebook.
Yeah. Okay. You guys have an argument for everything. So I cannot win. So I give up. I will do the grading using Microsoft. How about that?
I mean, it could be easier to just send you via email. Is that not easier?
No, not you. See, you guys are not my problem. I think Moses probably understands. I teach a 55 student class, and I have to do something about that. And that they are not flexible. And this is an introductory level class. I think they're grading everything. The rigor matters there. A small error is misused, I should say. I think
this is why all the math departments just use like web work. It's like a auto grader.
Oh yeah. I was considering that actually. Yeah. How do you know web work? Yeah.
In my undergrad, since there was no graduate program there, I guess the junior and senior students would put together stuff through web work and make assignments, and it's one of the things that I did.
I was seriously considering using that, but then at the end, what I realized is that I had to maintain my own webpage for that. Probably SIU doesn't have that here, so. Yeah, it's the time constraint that I let it go basically.
And there's another.
That's what I want to do, but now it is physical homework at this point. I was using WebAssign earlier. Go ahead.
Is the course? Which course is it? The 55.
Algebra-based physics.
Oh, there's so many. Yeah, there's so many pre-made, but you would have to teach towards those assignments more or less. But so you may have to change your teaching.
Yeah, I don't mind typing it. I want to type it because I want to make my own questions so that I can.
Okay.
So that is, I think, what changes the course altogether. Like my introductory level courses doesn't go like the one that is going here because my homework is not there. But this time it is going good because this time it's physical homework, so it's my homework. So I'm able to manage better. So I ask them to plot and they don't know how to plot, right? Otherwise, what I do is I give them all the web assigned homework. And then in the exam, I ask them to plot. And there are at least 10 students, they have never heard the word plot. At least they pretend to be. I don't know if they have heard it or not. They say, I don't know what a plot means. So now I give them a homework, plot 1 over X or something like that. So now they.
Yeah, the WebAssign stuff, it's at first it kind of sucks to write everything, but in the end, I think it's definitely a worthwhile investment if you're planning to teach courses online. And it'll save you time because it grades it for you. And
yeah, I know.
It gives them multiple submissions. Like you can choose how many times you want them to attempt a problem before they lose points on it. Or
True.
It's good because it forces students, like, so you know immediately, like you turn in something and then it tells you that it's incorrect. It forces the student to really mess with the problem instead of just being like, that's good enough, we'll just have to go with whatever he gives me the grade for. But whenever we got good feedback from students on it because they and the students did better in the course because they practiced problems a lot more.
I agree to that. I've also got the same feedback because I've done it before without WebAssign, and after WebAssign there was a significant at least interest in it. They like the fact that they get feedback, especially when you give multiple, like I give them 5 choices and all, or 5 times 5 attempts. So they like it. But my problem is that in WebAssign, you have to go with standard textbook problems. And then I make an exam, which is not a textbook problem. In the exam, I ask my questions. And
Yeah, that's WebAssign. But did you look into web work?
Web work, that's what I was planning to do, but they want a website. So they will run it for you if you pay some $100, $200. It is free. But I have to make my own website. I have to be the administrator there. And I was not sure whether I want to take such a big responsibility at a big classroom. If something goes wrong at the website, like the whole course goes down, right? So yeah, I had only 1 week, so I gave up on that.
Yeah.
But something in the future,
Yeah, I have the same problem as I don't like them to get used to a set type of problem. So they have WebAssign for practice. And then when it gets closer to the first quiz, I give them a set of review problems that they have to work out by hand that I wrote. And that way,
they know
they're able to see both sides.
That's correct. Yeah. Yeah, that's a good point. But then I should have that many questions. Yeah, that's for that you have to teach. See, you have taught probably many years. You have a good bank, I suppose, of your own.
Wait, so are you a teacher?
Yeah.
Yes.
You teach in Carbondale or?
I teach at Olney Central College.
Oh, awesome. So you teach like physics or math or?
I teach mostly physics. I teach a couple of the engineering mechanics courses.
Oh, so you're the guy I need to be calling up whenever I have questions, right? I'll be calling you for all the insights.
So it's a joy. I've had some excellent students over the years.
Right. So how many courses do you teach?
Usually, I used to teach more, but I told them that I'm cutting it down. So I'm only teaching 4 or 5 courses. But at the community college level, that's the amount of work, me cutting my schedule down and now doing this, I really haven't increased my workload. I've just shifted it.
Got it. Wow. And how many of you are there in the department?
I'm the only person in physics at our school. We have somebody at one of the other schools, we try to talk together, but it's just, we're
Yeah, I
we're
know.
geographically separated by about 45 miles.
No, I know. Yeah, yeah. I think my wife teaches in a community college here.
Okay.
She started recently, like 2 years.
John A. or?
John.
Hey, this semester I'm just doing the 101 course, the lab course, which is like very easy to grade. So if you wanted to use my Surface this semester to grade, you're more than welcome, because I'm not even really going to open it. So if you wanted to,
I have a tablet that I can use. So since I have made this such a big discussion now, so I better use this Microsoft and get some good grading done. So I'll figure it out.
I just did a cursory search, and I found that there's a program called Shutter for Ubuntu. I don't know if you've looked at that.
I haven't done anything. See, that's what I usually do is that for me, plug and play is very important. If it doesn't work, I don't even depend on it, because 2 years later, that won't be there. All these programs come and go. I don't want to learn something that's not there, going to be there for 2 years. Like LaTeX is great. Give me something like LaTeX.
Mhm.
Like it's like video recording. These days we have video recording. I want to edit. In Linux, it's the same thing. It's not a good program out there. And I don't want to learn something that won't be there 2 years later. Give me something that will be there for 20 years. Like anything, I don't want to learn which will go away. If people should have spent time on it. If the builder has not spent time on it, I don't want to learn that.
that makes perfect sense. Yeah, I've done that plenty of times. I learned something that's not there anymore.
So for recently the challenge was to use a whiteboard program for recording, right? So I am making the solutions for the same class. So I don't want them to see. I can actually, so while teaching, I'm just teaching it on the physical whiteboard. So do it on the computer. So Zoom has that feature, that's perfectly fine. But that's going all the way across the cloud and coming back. And often the quality is not perfect. So it should be much more simpler. And there is something, the best one for that is what is called Open Board for Linux. So that's good enough. Like for 10 years, they have built it, but it's still in version 0.3. So I don't mind learning it, but I'm saying I'll learn for 3 years. And what if the developer says that, okay, I'm done with it. I'm not going to spend time on it. And I'll be having 50 files which have used that, and probably it won't be compatible with something else. So one has to be careful about what you use when you're doing it for 30-year period.
That's kind of the problem with Ubuntu, though, is that everything is open source. And so anybody can edit and change. And
exactly.
So the moment somebody comes out with something better, unless people are interested in putting time and effort into this thing they've used, it just dies off. So that's
why I say LaTeX-like software, something that people have really spent time on and they've really got good reviews. Once it reaches version 2, then it surely will take off. And then it's okay. So at least version 2 should be there.
Basically, what you're saying, or from what you're saying, is the D2L annotation is the limiting factor. It's just not great. And if we had a different system, that would be better for everyone.
Linux-based users, it doesn't address the Linux-based user. It addresses probably Mac and Microsoft.
Even for, I mean, for Mac users and PC users, like what you were saying, Jordan, like you used another program to help you annotate, because the annotation tool built into D2L is just not great.
Yeah, it's not great. That's the problem. That's the one place that D2L, for a university that, you know, in this COVID times that we need to be using online stuff, D2L is not the answer for sure. D2L is like a facilitator to seeing your grades online, basically. That's the extent of its ability, I think. It's not really meant to teach students online. And even you know, last semester when we did quantum online, he used the D2L, you know, what was it called? The virtual classroom. And it's hard to write on the screen.
Yeah.
And then it's
Exactly, yeah.
it tries to straighten every curved line. You know, it's not virtual classroom D2L. It definitely was not built for, because I had trouble during my office hours and during, you know, my tutoring hours or whatever to help people out using D2L. So I just ended up sharing my screen through D2L and then using software on the computer itself instead. This is just a lot better and easier.
Do you know how much detail costs?
I know it's pricey. I don't know.
I'm sure it is.
I think they do their package based on the enrollment.
Enrollment, yeah.
So it costs carbon, it costs us.
You have to think too, you're in the minority, like math and physics. Those environments are in the minority of the usefulness of D2L.
Yeah.
Whereas, you know, if you were in history, you know, it says go read this and then submit an essay describing what you read or write a summary of this. Or so for a lot of departments, it's fine. But when you need to grade or write an equation, and it gets a lot more difficult, I think, for like math and physics and engineering, and, you know, where it requires funky letters or.
Yeah.
They had a thing called Angel several years back.
Okay.
Blackboard acquired them, but they were the only learning management system that had a decent problem editor.
Problem.
You could write problems, and you could do multi-step problems. You could use you know, scientific notation for the constants that worked really well in it. Like Canvas has a tendency that at a certain point it's zero, or you know, anything that's got a very small or large negative exponent, it's zero. and this one did a great job, and you could also do you could put multi-step problems into it.
Yeah.
And it was awesome. We were using it, and Blackboard decided to buy them, so the price shot up, and then we went to D2L.
This is another problem. Like, for example, if you're using any software, or this is the problem with private software, right? You got to be careful that they will last. They will keep funding it. Otherwise, you will be dependent on it because you have 10 years of data on it. Like when I went to Zoom, for example, that was one of the issues. Like if you have your lectures, I want to make sure that you get the videos in your hand. Right? You don't want to have it somewhere else. And then if you're dependent on it, this is not very important. They shouldn't be having any
I think
rights on it. But this was relatively simple. It came out easy. And again, Zoom is, like I've used Zoom for a long, long time, at least for collaborations of math oriented. Zoom, I think, is the best. It beats everything else. I'm not a fan of Zoom as a corporate or anything. But when you think of it as any other, like Skype is there, Hangout is there, it does turn out to be much more smoother for some reason as a simple user and so on. But that doesn't mean that its writing tool is good. Like when you use the whiteboard, it is not. I see issues there. Like it's not the best. Like for example, maybe it is possible. I couldn't easily import like what I wanted to do was I import my homework file and then write on it. Right? I couldn't do that easily. So there's a lot more to do in there. Maybe like these times will bring out all these things. Like I know that I have a friend in Boston who works with high school students. So they came up with this venture idea that they want to give avatars to students. So you have the same feature where the student comes in and you can actually see each other. You see Avinash, but not as Avinash, like you will create an avatar. I don't know how, and then you will see this whiteboard in there. So it's a three-dimensional field in there. It's just a very early proposal in there with the high school students, but I'm sure there are others thinking along the same line, and something like that will come. Is it going to replace classroom teaching? I don't think so. I feel that this is
no way. No way.
I feel this is very rich.
Yes.
This cannot be replaced very easily. So hopefully they realize all this. Yeah, you should. Yeah. So all of us should leave. Yeah. Okay, Jordan. Thanks for all the input.
Yeah, I don't know if it'll help you because you're. I see your issue with the large classrooms, but I mean, who can you talk to at the university to try to like put forth?
Oh, I usually don't. With my experience, again, I keep this to like even students. I usually don't point this out. Like usually, no one knows that I use Linux. Like I just avoid this whole thing.
Yeah, but that doesn't help you though, you know.
Discussion, because as you are suggesting, there will be 5 suggestions given to you, which are all reasonable, and in the first 5 steps it will all work, but in the 10th step there will be problems.
Mm-hmm.
Experience-wise, I just don't even try many of those. But this one seems maybe I'll try some, at least a couple of steps I'll do, maybe do this, do that. We'll see how it goes.
Just tell Moses to figure it out.
No, he's going to do it on his own, but I want to grade few things on my own so that I know the students, so that is my problem. Yeah, I can actually give everything to him, but I think I want to grade a little bit. So
Yeah.
I haven't resolved that problem either in terms of a good annotation tool. Because yeah, I mean, basically you have to, either download the file and upload it into another program or take a screenshot and, edit it on the screenshot, but there are extra steps that you have to go through to do that.
Yeah, make it simple, I would say. Make it efficient, because otherwise, see, you have to do this for the whole semester.
Right, no, of course, yeah. I'm in the same boat as you. I'm interested in the most efficient method.
Make it efficient, because it shouldn't become that, I have to grade for 10 hours, so you won't even grade.
Yeah.
So you want to get things done. That's more important. Even without a feedback is better than not getting done at all. So
yeah, right. I mean, and so I'm probably erring on the side of more just like written text feedback rather than trying to write stuff. So
that's okay. Yeah.
That's kind of the way I handled last semester, because I had a lot of labs to grade, and whenever we switched to all online, I was having them turn a physical copy in at first, and then I was just giving them a grade and then handing it back to them. And then when we went all online, I didn't know how to handle it at first, because it was just a lot. Each lab was like 6 or 7 pages long, and there's 50 of them. And how do you write something on every single page? Like, oh, this is incorrect, this is incorrect. But I just would, at the very end, I would, where I put the grade, I would say in actual English words, here's what you missed, here's what you need to work on. If you have any questions, contact me. And that seemed to work out pretty well. And you'd see consistent, and I think there's not a lot you can do, unfortunately.
Yeah, it's tricky. Yeah, if you have to write equation, like for your classes, you guys were only one handful of students, and I used to print them and then scan it back. That itself was too much organization. Like my email used to get full. Like there are 15 emails I have all about homework, and then I have to print it and make sure that they are ordered, staple it, then grade it, then again scan it. It's too much organization. So it was okay. I managed it last semester. I can do it this semester, but yeah.
No, yeah, definitely not. Definitely not. That's too much work, especially when you get to all the courses.
And it discourages.
There's only like 3 or 4 of us in both the courses last semester, so.
Yeah. And it discourages you. Main thing is that usually grading is not the first thing you want to do. And if there is an added feature that, this is going to be such a long work, you don't tend to finish it off. You don't even start, actually.
Yeah.
But Moses, get it done. So, yeah, because I think there is a large class. I mean, they appreciate it. That's all. I mean, if it is regular, I wanted there should be a pattern that, oh, they should always see that. So they kind of like it. That's all I want.
Yeah.
And we just,
Yeah, because I think the big thing right now is everybody expects the virus to move on, and next year we won't even have to think about it type deal, and we'll just go back to business as usual. So I'm sure from the universities high end side, they're saying like, well, yeah, there's some options for us, but is it worth spending the money on those options for a year? Then, or just saying like, hey, education's not going to be as good this year. Everybody worldwide knows that. Do we just accept that? Well, when push comes to shove and it's like, well, it's going to cost you $1.5 million in order to fund this at the university level. I don't even know if that's enough. They probably say no. We'll just get our money from students and then have the professors have headaches and students be upset, but we'll just say, it's coronavirus year. What can you do? It's unfortunate. So next year will be better when we're in person.
yeah.
Who knows? Anyways.
Okay, I think I should get back. I have another class at 2. Yeah.
Good to chat with you guys.
Yep.
Yeah.
Good chatting.
Thank you for the feedback. Yeah. Okay.
All right.
Enjoy. Yeah.
Good luck with your courses.
Tell that again. I didn't hear you. What?
I said, good luck with your courses. I'm glad I don't have that many.
Okay. Enjoy.
See you,
Goodbye.
Melissa.